Let's look at adding and subtracting radical expressions. Make sure you have watched the video on simplifying radicals first, because you're going to have to be able to do that in order to add and subtract. So in order to add and subtract radical expressions, we have to have a couple things be true. One, the radical expression has to have the same index as the one that you were adding or subtracting from or to it. And two, the radicands have to match. What's under the radical has to match. So in this first problem, it appears that you can't add them because we have a 24 under the first radical and we have a 54 under the second one. However, you can't know for sure whether they are alike until you simplify them. So we're going to use the skills from another video to simplify these. 24, I'm going to pull out its perfect square factor, 4 times 6. 54, 9 times 6. Now I can take the square root of 4, it's 2. It comes out and gets multiplied by what was there. So 6 radical 6 plus square root of 9 is 3. 3 radical 6. Now my radicals actually do match. They're both a square root and they both have a radicand of 6. So it's almost like saying 6x plus 3x is 9x. You can think of it that way. So 6 radical 6 plus 3 radical 6 is 9 radical 6. So it's combining like terms once you get those terms to look alike. So let's look at B. Again, they first don't appear to be the same, but we're going to break them down and see if they are. So the perfect square factor of 20 is 4 times 5x. The perfect square factor of 45 is 9 times 5x. Square root of 4 is 2. That comes out front, and we have 4 square roots of 5x. Square root of 9 is 3. Minus 3 square roots of 5x. Now my radicals do match. They have the same radicand and the same index. So 4 of those, take away 3 of those, is 1. And you can put the 1 or not. I will in this case. 1 radical 5x. Let's look at example C. I have 2 radical 3 minus 4 radical 5. My radicals don't match, and I can't break them down. If this was multiplication, it wouldn't matter. I could just multiply it together. But because it's subtraction, I can't combine those unlike terms. So you can write simplified already, or can't be simplified, or whatever you want. You can just rewrite 2 radical 3 minus 4 radical 5. It cannot be combined is the point. All right, let's continue with some that are not square roots. So here I have 2 cube roots of 16 minus 5 cube roots of 54. Once again, we have to think of those perfect cubes. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, etc. So 2 cube roots of, I want to break 16 into one of the factors from this list. So 8 times 2. Minus 5 cube roots of, what goes into 54? 27 times 2. Cube root of 8 is 2, so I have 4 cube roots of 2. Cube root of 27 is 3, minus 15 cube roots of 2. 4 of those, take away 15 of those, is negative 11 cube roots of 2. Let's look at some that have variables underneath. I have 2 cube roots of x squared y plus cube root of 8x to the 5th y to the 4th. This first one can't be broken down, and I know that because the exponents in the radicand are smaller than the index, so there's not enough to pull any out. So I'm just going to leave this. There's nothing I can do with that. 8 is a perfect cube, so I don't need to break that down. We learned in another video that X to the 5th we want to break down into something divisible by 3, so x cubed and then x squared, and y to the 4th, same thing, y cubed and y. Now I'm going to pull out of this one what I can. Cube root of 8 is 2, cube root of x cubed is x, x squared won't come out, cube root of y cubed is y, y won't come out. So what's left in this second one is an x squared y. This one wouldn't break down to begin with. Now notice, I'm going to use a different color here. The radicands do match. The indices do match. So I should be able to combine, but the problem is that the coefficients are not like terms. I can't add a 2 plus a 2xy. There's really nothing you can do with that one. You could factor out the radicand or the radical sign, but it's not necessary. I would just leave it in this form. So it's just 2 cube roots of x squared y plus 2xy cube roots of x squared y. There's nothing you can do to combine them. Even after you broke them down and the radicals matched, we can't put them together. Looking at this one, we're back to a square root here and a cube root here. So there's no reason to even break it down because the index doesn't match. So even if I could get the radicands to match, I can't combine them because of the index. So this one can't be done. Can't be combined. It's just as it is. All right, let's look at the bottom. And we're going to do some combining in subtraction or addition, but it's going to be fractions. So like with all fractions, we have to have a common denominator. In this case, my common denominator is 8. So my second fraction is already good to go. Here I say, what do I do to 4 to get 8? That's times 2. So you have to do the same thing in the numerator. And here is where you have to be careful. You're multiplying the number part, not the radical part. So 2 times 3 is 6, radical 7. So I have 6 of these. Take away 3 of these gives me 3 radical 7s over 8. Just adding one more layer with the fractions. In part B, my LCD is going to be 9. Again, my second fraction is already in that form. What do we do to 3 to get 9? Times 3, so it's 12 radical 3. So I have 12 radical 3's plus 2 radical 3 is 14 radical 3, and it is still over 9. And I can't simplify this because there's nothing that goes into 14 and 9. Please be cautioned. You can't cross cancel a number outside of a radical with a number inside of a radical. This isn't really a 3. It's a square root of 3, and that doesn't cancel with 9.